You know, I gotta be honest with you. I don't trust stairs. They're always up to something. Okay, in this video, we are talking about how we calculate net force acting on an object. So, here's the point. By the end of the video, you should be able to calculate that net force and predict the change in motion of an object based on that net force. And here's the good news. The math is extremely simple when it comes to this. It's just a matter of kind of looking carefully. So, you've seen this before. How do you predict whether an airplane is slowing down, speeding up, climbing, or descending? You look at the four major forces acting on it and see if there is a difference in some of them. And so what we did in the previous video was we just looked at the relative size. Is one arrow bigger than the other? But now we can actually start to put some numbers on it. Just like when we look at unbalanced forces versus balanced forces, we can either look at the size of the arrows or the numbers of the force involved. So again, in this balanced tug of war, it's 300 newtons going in either direction. But in this unbalanced one, it's 400 newtons going to the left and 300 to the right, causing an unbalanced situation where more of it is going to the left, and that is the direction it's going to start moving. So let's take a look at our airplane again. Imagine our airplane is producing 10,000 newtons of thrust, but the force of drag, the air resistance, is only 9,000 newtons. So what is the net force on the plane? Well, if you think about it, this 9,000 is sort of canceling out all but 9,000 or all but 1,000 of the thrust, right? So 9,000 of this thrust is just to oppose that drag, leaving you an extra 1,000 newtons. So we can look at it this way, right? It's 10,000 newtons to the right, plus 9,000 to the left, and that's going to give us a total net of 1,000 to the right. 1,000 to the right. It's going to end up pointing in the direction that we have the bigger force. So the plane is accelerating to the right. In this case, this plane is speeding up, right? Speeding up, it's accelerating in the direction of the thrust. So here's how we calculate net force. We add forces when there's more than one force in the same direction. We subtract if they're in the opposite direction, and then we just determine that it's accelerating in the direction of the greater force whenever it's unbalanced. So if net force is 0, that means they're balanced. The object is not accelerating. Its motion is not changing. But again, remember, it may still be moving at a constant velocity. Something that is already moving at a constant velocity that gets affected by balanced forces is still going to move at that constant velocity. Okay, so let's go to a rocket example. Imagine we've got a rocket with a weight of 500,000 newtons. And keep in mind that is a force. That's the force of gravity. And the rocket produces 1,000,000 newtons of thrust and experiences 200,000 newtons of gravity. 200,000 newtons of drag. What is the net force acting on the rocket, and what is happening to its motion? So let's take a look. We said thrust was 1,000,000 newtons. It's 1,000,000 newtons upwards. That's represented by the blue arrow here. But we've got to subtract the ones that are pulling it in the opposite direction. So 500,000 newtons are pulling down. That's the weight. 200,000 additional newtons pulling down, that's the drag. So when you subtract those all, you get 300,000 newtons, and it's going to be, the net force is going to be in the direction of the biggest force, which happens to be the thrust. It's 300,000 newtons upwards is the net force, and it tells us the rocket is accelerating upwards, right? It's accelerating, it's changing its motion in an upwards direction. Now let's try a variation on the same thing. We've got a rocket with that 500,000 newton weight. It's moving upwards by producing 700,000 newtons while experiencing 200,000 newtons of drag. What's the net force and what's happening to its motion? So again, we can just subtract the ones moving in the opposite direction from the bigger one being the thrust. So 700,000 minus 500,000 minus 200,000 is a net force of 0. The net force is 0, meaning that its motion is not changing, but still moving upwards at a constant velocity. Doesn't mean it's not moving, it just means it's not having its motion change. And that is how you calculate net force. It's addition or subtraction. All you got to do is pay attention to the direction, do addition or subtraction, and you are good to go. So I hope that helps. I will catch you in the next video.